One day, imagine you step outside your house and instead of a simple blue sky, you see a massive bright streak across the sky. From one end of the horizon to the other, it's clearly visible whether it's morning or night. You can't help but think that this looks like a scene from a science fiction movie. But unbeknownst to you, there are scientists who believe that this might have been exactly what the Earth looked like in the past. For a long time, we've known Saturn as the planet with beautiful rings. But according to new studies by researchers, it's possible that our planet also once had its own ring millions of years ago. This isn't mere speculation. In the study of ancient impact craters left in different parts of the world, some scientists noticed a strange pattern, and this is the arrangement of the craters, which seems to indicate that there was once a large amount of material orbiting around the Earth. If this interpretation is correct, it's possible that a ring was formed after a massive collision in space. It's possible that an asteroid or another large celestial object came too close to Earth and was broken apart by the planet's intense gravity, and its fragments didn't immediately fall to the ground. Instead, they remained orbiting around the Earth and gradually formed a massive ring system. According to some studies, this kind of system could last for more than 10 million years before it completely disappeared. This means that for a very long time, the sky looked very different from what we see today. Despite this, if Earth really did have rings before, what would they have looked like? And that's what we're going to find out. But before we start, don't forget to like this video. It means a lot to us content creators. Thank you very much, and now let's get started. First of all, if Earth really had a ring before, it wouldn't be like Saturn's. Saturn's rings are mostly made of ice, which is why they look so bright. In Earth's case, it's more likely made up of rocks and dust with a high percentage of silicate minerals. Because these rocks don't reflect much light, the rings would appear paler in color. Instead of a bright white, it would look more like a broad ash-colored band, or a slightly reddish streak hanging in the sky. And what you see would not be the same, depending on your location on the planet. If you live near the equator, it might just look like a thin line crossing the entire sky. But as you move farther from the equator, the part you see becomes wider. In some places, it can look like a huge arc covering a large part of the sky. In regions at mid-latitude, this could be one of the most spectacular views in the entire sky, because here you can clearly see a permanent structure in the sky that doesn't disappear and has been visible for many generations. And when night falls, the scene becomes even more extraordinary. The dust and small rocks within the ring can reflect and scatter light from the part of the Earth that is illuminated by the sun. Because of this, there will be a faint light even in places that should have been dark. In other words, the night might not be as dark as the night we are used to now. For millions of years, ancient creatures may have lived under a sky with a massive ring hanging above them. A view that, for us, seems like pure imagination, but it may have been part of the real history of our planet. Nevertheless, of course, a good theory alone isn't enough to convince the scientific community. Strong evidence is needed, and this is where the story becomes even more interesting. When geologists examine rocks that formed during the Ordovician period, an ancient era in Earth's history that occurred about 466 million years ago, they noticed something unusual. In different parts of the world, there was a sudden increase in materials commonly associated with meteorites. It's as if, during a particular period of time, more objects from space reached our planet. For many decades, the most common explanation was that a large asteroid in the asteroid belt between Mars and Jupiter broke apart. So a collision happened, spreading a lot of debris, and some of those pieces hit Earth. The explanation seems simple. But when researchers closely studied the locations of ancient impact craters, a mystery began to emerge. In 2024, a research team from Australia used modern computer models to trace back the previous positions of the continents. This is important because the Earth didn't look the same back then. The continents have been continuously moving for millions of years because of plate tectonics. And after the scientists adjusted the locations based on the ancient map of the Earth, an unexpected result came out. Instead of being randomly scattered across the planet, most of those impact craters seem to be concentrated in a narrow area near the ancient equator. And that's when the scientists began to ask if the rocks really just came from a random asteroid breakup in space. Why does it seem like only a particular region on Earth was hit more? In a normal situation, you would expect the debris to hit different parts of the planet without any clear pattern. That's what we see in more modern impact events, but what was observed in the craters from the Ordovician period was different. It's as if there was some mechanism directing those materials to hit a particular zone of the Earth, and this is where the idea that Earth once had rings was born. According to the hypothesis of some researchers, it's possible that a large amount of rocks and debris once orbited around our planet. As these materials gradually fell from orbit, it was also more likely that they would end up in areas near the equator. In fact, this is not yet considered a proven fact. Many scientists still say that more evidence is needed before this concept can be fully accepted. But what's important is this. For the first time, there is an emerging explanation as to why a unique group of impact craters formed almost 500 million years ago. And if this interpretation is correct, it's possible that the craters we see today are not just traces of asteroids. They could also be the remaining traces of something that disappeared from our sky a long time ago. A massive ring that once orbited around the Earth and gradually changed the face of our planet. But there is one big problem with the asteroid breakup theory. If it's true that a massive asteroid broke apart in the asteroid belt and released millions of pieces throughout the solar system, Earth shouldn't be the only one with traces of it. We should also see its effects on Mars and even on the Moon. In fact, Mars is even closer to the asteroid belt than Earth. If there was a widespread shower of asteroid fragments in the past, there's actually a higher chance that the red planet received even more impacts. The Moon, on the other hand, is like a natural archive of collisions in space because it has almost no atmosphere. So craters remain there for a very long time. That's why scientists began to ask if there really was an extraordinary asteroid event in ancient times. And if so, where are the similar pieces of evidence on Mars and the Moon? In the early 2020s, researchers examined 24 large craters from Earth, Mars, and the Moon to see if there was a similar increase in impact events over the past 600 million years. The result was surprising. While there was a noticeable increase in impact records on Earth around 466 million years ago, the same pattern was not as clear on Mars and the Moon. Because of this, scientists were divided in their opinions. Some say that the grouping of craters on Earth might have just been a coincidence. It's possible that the impact sites in certain regions were just better preserved, which is why we see more evidence there today. In other words, maybe it wasn't actually that more asteroids fell there. Maybe it's just that more evidence survived over time. But there's another, stranger explanation. What if those rocks didn't come from a distant asteroid breakup between Mars and Jupiter? What if the event itself happened close to Earth? This is where the concept of Earth rings comes in. According to the hypothesis of some researchers, there might have been a huge asteroid that came very close to our planet. It didn't collide directly. Instead, it entered a very dangerous distance where, as they say, Earth's gravity started to dominate. When a large object gets too close to a planet, the pull on it becomes uneven. The Earth's pull is stronger on the part closest to it than on the part that's farther away. This is called tidal force. This is also the same principle behind why we have high tide and low tide in our oceans, because of the influence of the Moon. Usually an asteroid's own gravity is enough to keep it intact. But when it gets too close to a planet, the tidal force can overpower it and slowly break it apart. Scientists call this the Roche limit. This is the boundary where the planet's gravity starts to overpower an object's ability to hold itself together. When that limit is exceeded, the asteroid can break apart into thousands of pieces. And this is where the more unusual part of the story begins. Instead of the fragments immediately escaping in different directions throughout the solar system, it's possible that many of them stayed around the Earth. At first, their movements were chaotic. Some pieces moved closer to the planet, some pieces moved away, some had elongated and irregular orbits. But over time, the debris continued to collide with each other. With every collision, the chaos of their orbits decreased. Gradually, they settled into more stable movements until they formed a wide circular disk around the Earth. And why did it form around the equator? Because our planet is not a perfect sphere. The Earth is slightly wider at its middle part than at the poles. Because of this, the planet's gravity has a small but important effect on the orbiting debris. Over millions of years, this process gradually aligns the fragments' paths until almost all of them are positioned in the same orbital plane. The result? A vast ring of rock and dust surrounding the planet. If this theory is correct, the impact craters that scientists are studying today may not simply be traces of random asteroid strikes. They could be the last remnants of an ancient ring system that once gave Earth an appearance almost identical to Saturn. And even more surprising, Earth is not the only planet that may have had rings. Some studies show that Mars may have also gone through this stage. According to some planetary scientists, Mars' small moon called Phobos is slowly getting closer to the planet as time passes. It will not stay in its current orbit forever. In the distant future, it may reach a distance that is too close to Mars. When that happens, the planet's gravity may overpower the moon's structure, and it will slowly break apart. Instead of a moon, Mars may have a wide ring made of rock and dust. There are models that show that after the ring forms, a large part of its material may fall back onto the surface of Mars. The remaining part may come together again to form new moons. Because of this, some scientists suspect that this process has happened several times in the history of Mars. And if this is possible on the red planet, another question naturally follows. Did this also happen on Earth? At present, the most widely accepted explanation about the origin of our moon is the giant impact hypothesis. According to this, about 4.5 billion years ago, a large protoplanet, which scientists often call Theia, collided with the young Earth. That collision was extremely powerful. A huge amount of rocks and debris were thrown into Earth's orbit. Over a long period of time, those materials kept revolving around our planet before they came together and formed the moon that we see today. This means that according to modern planetary science, there was a stage in Earth's history when it was really surrounded by a huge amount of orbiting debris. And if that happened before, it's not impossible that a smaller version of that process happened again hundreds of millions of years after the moon was formed. But there's another reason why the idea of ancient rings around Earth is important. It doesn't just explain the impact craters. It could also be related to the planet's climate. Some researchers have suggested that if such a ring was thick enough, it could partially block the sunlight reaching Earth. This doesn't mean the whole world would become dark, but even a small change in the amount of solar energy hitting the planet could have a huge impact when we're talking about millions of years of climate events. There are studies looking into the possibility that this period is connected to the intense global cooling that happened during the late part of the Ordovician period. However, it's important to note that this is not yet considered a proven fact. The debate continues within the scientific community about how significant the role of possible rings was compared to other factors such as atmospheric changes and natural climate processes. And if Earth really did have a ring before, why is it gone now? The answer is simple. There are no permanent rings in space. Even the famous rings of Saturn will not last forever. In Earth's case, they would have disappeared even faster. As the rocks and dust orbit around the planet, they gradually lose energy due to various gravitational effects. Some of them spiral downward in their orbit. Others are affected by the thinnest part of the atmosphere. Over millions of years, these materials slowly fall back to the planet. Most of it turns into fine dust, but every now and then, larger chunks return from orbit. Imagine the scene if you were there at that time. At night, you would see a bright streak encircling the sky. Then suddenly, a blazing fireball would cross the sky, and another one for a very long time. For the ancient beings living on Earth, it might have seemed like the very sky itself was slowly falling, and the craters that scientists have found today may be just some of the remaining traces of that extraordinary chapter in our planet's history. A time when Earth not only had a moon, but possibly also had its own ring that could be seen from every corner of the world. But even if a massive ring did form around the Earth, that doesn't mean it would last forever. In fact, from the very first day it existed, it was already being slowly destroyed by the forces moving throughout the entire solar system. One of its main enemies is the sun. Our star doesn't just send out light and heat. It also continuously releases charged particles that travel through space as part of the solar wind. When these particles hit the dust and small rocks in the ring, there are changes in their electrical charge. Some of these materials can be influenced by Earth's magnetic field and gradually be diverted from their original orbit. If viewed from the surface of ancient Earth, this may have caused faint lights in the upper parts of the atmosphere. Not as intense as the auroras we see today near the poles, but possibly enough to give a unique glow at night. And with every small particle that disappears from the ring, it slowly gets depleted. But it's not just the sun that plays a role here. The moon is also involved. Every time it orbits around the Earth, it has a small but continuous influence on the debris in orbit. Over millions of years, the repeated pull of the moon's gravity can cause changes in the movement of the materials in the ring. Some particles may be thrown away from the Earth, while others may be pulled inward. Because of this, the shape of a ring system does not remain orderly and perfect. It gradually develops gaps, becomes thinner, and eventually collapses. This is one of the reasons why some scientists believe that if Earth ever had a ring during the Ordovician period, it probably did not last more than a few tens of millions of years. After that, it gradually disappeared. Now let's think about a more interesting question. What if Earth still had a ring in the present time? At first glance, it seems wonderful. A permanent decoration in our sky. A sight that would surely become a symbol of our planet. But in reality, it could bring a lot of problems. Almost all of our modern technology relies on satellites, GPS, internet, weather forecasting, telecommunications, and navigation systems for aviation and shipping. All of these depend on equipment orbiting in space. Now imagine millions of rock fragments and dust continuously orbiting between the Earth and those satellites. Even a tiny particle moving at very high speed can damage valuable equipment in orbit. Launching a new satellite will become more complicated, more expensive, more dangerous, and more missions could fail. In short, the modern world that we are used to today will become harder to run. But it's not just technology that will be affected. The climate could also change. According to some theoretical models, a thick ring could block a small portion of sunlight from reaching certain regions of the Earth. That might seem like a small thing, but in climate science, even just a 1 or 2 degree change in average temperature can have a huge impact on weather patterns, ecosystems, and agriculture. The cold season could last longer in some places. The distribution of rainfall could change, and organisms that depend on regular sunlight could be affected. But the biggest danger isn't the climate, but the things that fall from the ring. Most of the debris will burn up in the atmosphere as ordinary meteors. From Earth, it would look like a beautiful fireworks display that could be seen almost every night. However, not all fragments are small. Occasionally, there are larger chunks that can survive entry into the atmosphere. And when that happens, it's no longer just a simple shooting star, it becomes an impact event. A rock just a few dozen meters in size can cause massive destruction to a city. And if something even bigger falls, its effects could be felt around the world. So while an Earth with its own ring is beautiful to imagine, science also shows that it comes with risks. Maybe this is why ancient craters and geological clues that researchers are studying today are so important. They're not just trying to find out if Earth really had a ring. They're also trying to understand how an event that happened hundreds of millions of years ago could have changed the climate, the sky, and even the very history of life on our planet. There's another aspect of life that would probably be very different if Earth still had a ring today, and it has something to do with the way we study space. At present, we're able to send satellites, space telescopes, and robotic probes to different parts of the solar system because the space surrounding our planet is relatively clear. But imagine if there was a vast belt of rocks and dust orbiting between Earth and the higher orbits. Every rocket launch would become more complicated, more risks, more obstacles. Even just getting a spacecraft off Earth would require precise timing to avoid collisions with debris. Certain types of space communication could also be affected. When there are too many particles in orbit, there could be interference with some signals sent and received by equipment in space. Although it's difficult to determine the exact effects without an actual ring system to study, it's clear that operations would be more difficult compared to the current situation. Even ground-based astronomy could be affected. Right now, telescopes can detect the faintest light from distant galaxies, nebulae, and other cosmic objects. But if there is a permanent ring reflecting and scattering light in the sky, the night sky background could become brighter. And when the sky is brighter, it's harder to see things that are very far away and extremely faint. On the other hand, the view at night would be even more spectacular. On the other hand, we might have discovered some of the universe's most important secrets more slowly. Perhaps the history of science would also be different. It might have taken us longer to understand the true vastness of the universe. We might have had a harder time studying the stars, galaxies, and other planets. And here the question becomes even more exciting. Has the possibility of having Earth having rings again really disappeared forever? No scientist can say for sure. But according to some planetary researchers, ring systems are not a rare occurrence in the universe. Under the right conditions, they can form from collisions, the destruction of moons, or asteroids that come too close to a planet. This means that even though we don't see any rings now, it doesn't mean it's impossible for them to form again in the very distant future. Of course, if that ever happens, we won't be able to witness it. Many generations after us won't be able to see it either. But that's one of the most beautiful parts of science. Even if we didn't directly see the past, we are able to piece together the story using the traces left in stone, soil, and space. From a few ancient craters, unusual chemical signatures, and modern computer models, scientists are able to build a picture of a world that disappeared long ago. An Earth that might have had a different sky. An Earth that may have had its own ring. And although this idea has not yet been fully proven, it shows just how much we still don't know about the history of our planet. Because if the new studies are correct, for millions of years, the creatures that lived before humans ever existed looked up at a view that we will never see again. A vast ring that once surrounded the Earth and gradually disappeared, becoming just one of the mysteries that modern science is now trying to solve.